Hello dear students, this is the third class of trigonometry. In this class we are going to finish this chapter. Okay, here we have a question. Evaluate the following. We need to find this first question. 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta. Okay, this is the first question. What is given? 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta. Okay, here we know that tan theta is equals to what? Sin theta by cos theta. Sin theta cos theta. Secant theta is equals to what? 1 by cos theta. Okay, and cot theta is equals to cos by sin, cos theta by sin theta, and cosecant theta is 1 by sin theta. Okay, these are the known formulas. Now I'm substituting here in this 1 plus tan. What is tan here? Sin theta by cos theta plus 1 by cos theta. 1 plus cot theta is what? Cos by sin, cos theta by sin theta minus 1 by sin theta. Okay, now do LCM here. Cos theta is an LCM. Okay, cos theta. Then cos theta into 1 is cos theta plus sin theta plus 1. Okay, this is an next sin theta. Here sin theta is an LCM. Okay, sin theta. We don't have any sin. 1 into sin theta. Sin theta into 1. Sin theta plus sin theta cancel. 1 time of cos theta. Sin theta cancel 1 time. 1 into 1. So can I write this as multiplication? Right, this is multiplication. I can write sin theta into cos theta. Sin theta and cos theta. Next, cos theta plus sin theta. Sin theta plus cos theta. Here can I rearrange? Cos theta plus sin theta, put bracket, plus 1 into sin cos theta plus sin theta. Can I write this is cos theta plus sin theta minus 1. So this is in the form of a plus b into a minus b. A plus b into a minus b. We can write a square minus b square, right? So I am writing this. So a plus b into a minus b is a square plus b square. This is a square minus b square. B square is 1. Okay, 1 square by sin theta into cos theta. Sin theta into cos theta. From here, a plus b whole square formula. A plus b whole square formula. What is a plus a square plus b square plus 2ab plus 2ab. So I am writing this. A square means cos square plus sin square plus 2 sin theta cos theta minus 1 by sin theta into cos theta. Okay, here we know identity. First identity, sin square theta plus cos square theta is equals to 1. Okay, this is the formula. Okay, sin square theta plus cos square theta is equals to 1 identity. So this is 1. Everything is 1. Okay, this is 1. So from here this is 1 plus 2 sin theta cos theta, so 2 sin theta cos theta minus 1 by sin theta into cos theta. So plus 1 minus 1 cancel, and remaining what we have here, 2 into sin theta into cos theta by sin theta into cos theta. Sin cancel, cos cancel, remaining is 2. Therefore we got an answer. What is the answer? We got an answer. Therefore 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta is equals to 2. That's all. This is the solution. This is the solution. 2 is the answer. Okay, that's all. Here we have a second question. Evaluate sin theta plus cos theta whole square. Second question. Sin theta plus cos theta whole square plus sin theta minus cos theta whole square. Okay, we know here a plus b whole square formula. What is that? A square plus b square plus 2ab. Okay, a minus b whole square formula is a square plus b square minus 2ab. Okay, remember this formula. Remember this formula. So I am writing this. A plus b whole square means this is sine square theta plus cos square theta plus 2 sine theta into cos theta. Okay, this is a plus b whole square. A minus b whole square is next. Sine square theta plus cos square theta minus 2 sine theta cos theta. Okay, 2 sine theta into cos theta plus 2 sine theta cos theta minus 2 sine theta cos theta cancel. Sine square plus cos square is identity 1. We know identity sine square theta plus cos square theta is always equals to 1. So this is the formula. So this is 1. Okay, this is 1 plus this is 1. Okay, this is 1. Therefore 1 plus 1 is 2. Therefore answer is 2. 4 sin theta plus cos theta whole square plus sin theta minus cos theta whole square is equals to 1 is the solution. Sorry, 2 this is. 2 is the solution. That's all. Here we have a question, third question. A given question, first write it. Okay, secant square theta minus 1 into cosecant square theta minus 1. Now we know that secant theta is equals to 1 by cos theta. Okay, next. Cosecant theta is equals to what? 1 by sin theta. So this is the formulas. Next, here secant theta can be written as 1 by cos theta. Whole square is there. So square, see cos square minus 1 into this is 1 by cosecant is 1 by sin. So square is there. Sin square theta minus 1. I put here square because here square is there. Square is there. So do LCM 1 minus cos square theta by cos square theta. Okay, into 1 minus sin square theta by sin square theta. Okay, we know identity. What is identity? Sin square theta plus cos square theta is equals to 1, right? If I bring this cos square theta to the right hand side, can I write sin square theta is equals to 1 minus cos square theta? So I can write in the similar way, bring this sin square theta plus cos square theta is equals to 1. This is 1. Okay, if I bring this sin square to the right hand side, I can write cos square theta is equals to 1 minus sin square theta, right? So 1 minus sin square, in the place of 1 minus sin square, can I write cos square? In the place of 1 minus cos square, can I write sin square? So I am writing here 1 minus cos square can be written as 1 minus cos square can be written as sin square theta by cos square theta into 1 minus sin square. In the place of 1 minus sin square, can I write cos square theta by this is sin square theta, right? Sin square cancel, cos square cancel. This is 1 time. So this is 1. That's all. This is the 1. Therefore, you are getting the solution what? Secant square theta minus 1 into cosecant square theta minus 1 equals to 1 is the solution. Okay, done. Simplify secant a into 1 minus sin a into secant a plus sin a. So given here secant a into 1 minus sin a into secant a plus tan a. Okay, here we know that. We know the formula. We know the formula what? Secant a can be written as 1 by cos a. Okay, next tan a can be written as sin a by cos a. Okay, these are known formulas. So here secant a can be written as 1 by cos a into 1 minus sin a. This is 1 minus sin a into secant a can be written as 1 by cos a plus tan can be written as sin a by cos a. Sin a by cos a. So 1 by cos a into 1 minus sin a into here LCM is cos a. So 1 plus sin a by cos a. Okay, so 1 minus sin a into 1 plus sin a is 1 square minus sin square a. Okay, this is a plus b into a minus b formula. A plus b into a minus b formula is what? A plus b into a minus b formula is a square. This is the formula. So 1 minus sin a into 1 plus sin a is 1 square minus sin square a. Next, cos a into cos a is cos square a. Right, cos square a. And we know identity sin square theta plus cos square theta is equals to 1. Bring the sin square to the right hand side. So cos square theta is equals to 1 minus sin square a, sin square theta, right? So in the place of 1 minus sin square theta, can I write cos square? So I am writing here cos square. Cos square a by cos square a. Both are same, so hence 1 is the answer. And 1 says 1 is the answer. Therefore, the solution is given. For a given question, we have a solution, that is secant a into 1 minus sin a into secant a plus tan a equals to 1. This is 1. This is the solution. Okay, done. Here we have a question. Prove that sin a plus cosecant a whole square plus cos a plus secant a whole square is equals to 7 plus tan square a plus cot square a. Now here given LHS. First consider LHS and prove RHS. Okay, LHS means left hand side. So left hand side part is sin a plus cos a. Sin a plus cosecant a whole square plus cos a plus secant a whole square. So here a plus b whole square, apply a plus b whole square. We know a plus b whole square formula is a square plus b square plus 2ab, right? Use this formula. So I am using here a plus b whole square is sin square a plus cosecant square a plus 2 sin a into cosecant a plus this is cos square a plus secant square a plus 2 cos a into secant a. We know that cosecant a is what? Cosecant a is 1 by sin a. Okay, next. And secant a is what? Secant a is 1 by cos a. Right, this is a known. I am writing same. Sin square a plus cosecant square a. I am writing same cosecant square a plus here 2 sin a into cosecant a is what actually 1 by sin a, right? Sin a plus cos square a plus secant square a plus 2 cos a into secant a means what? 1 by cos a. So here cos a cancel, sin a cancel. So sin square a cos square a, here we have sin square a plus cosecant square a plus this is 2 plus this cos square a plus secant square a plus this is 2 into 1 2, so 2. So we can write it as 2 plus 2 4 plus I am writing sin square a, next cos square a. Okay, sin square a plus cos square a plus cosecant square a plus secant square a. Okay, now here we know identity 1. Sin square theta plus cos square theta is always equals to 1. So using this 4 plus 1 plus cosecant square a plus tan secant square a. Okay, now we know the one more identity. What is identity? Secant square theta minus tan square theta is equals to 1 and cosecant square theta minus cot square theta equals to 1. Okay, these are the two identities, remaining identities. So what I'm doing here, sending this tan to the right hand side, sending to the cot to the right hand side. What I can write? In the place of secant square theta, can I write 1 plus tan square theta? Yeah, absolutely we can write. Now, we can write here cosecant square theta. In the place of cosecant square theta, 1 plus cot square theta. Right? So I'm writing 4 plus 1 is 5. So 4 plus 1 is 5. Plus cosecant square can be written as 1 plus cot square A. Plus secant square can be written as 1 plus tan square A. 1 plus tan square A. So your 5 plus 1, 6. 6 plus 1, 7. So 7 plus tan square A plus cot square A. Therefore, this is RHS, right hand side. Therefore, LHS equals to RHS. So LHS is equals to RHS. 7 plus tan square plus cot square, right? Tan square plus cot square. Hence we got this RHS. Therefore, LHS is equals to RHS. Repeat the question, same, right? Repeat the question here. Okay, that's all. This is a solution. Here we have a question. If cosecant theta plus cot theta is equals to k, then prove that cos theta is equals k square minus k square plus 1. K square minus 1 by k square plus 1. So, first write the given data. Here given, what is given? Given is cosecant theta plus cot theta is equals to k, right? Now, we know the formula. We know that cosecant square theta minus cot square theta is equals to 1. This is a formula actually. Okay, this is the formula. So what I'm doing here, we know a square minus b square is equals to a plus b into a minus b, right? A minus b. This is also one more formula. In the formula we are applying the formulas, right? Here a square minus b square. Okay, a square minus b square can be written as a plus b into a minus b. This is cosecant minus cot theta is equals to 1. So a plus b into a minus b. We are applying like a square minus b square. A plus b into a minus b. So a plus b formula we know. Cosecant plus cot is k. So I am writing here k into cosecant theta minus cot theta is equals to 1. So bring this k to the right hand side. It will become divide. Okay. Cosecant theta minus cot theta is equals to 1 by k. Therefore, let us call it, this is equation 2 and this is equation 1. Okay. Solving 1 and 2. Solving 1 and 2. Solving 1 and 2. So 1 implies what? 1 implies given question. Cosecant plus cot is equals to k. Cosecant theta plus cot theta is equals to k. Second equation implies cosecant theta minus cot theta is equals to 1 by k. Okay. Now, plus cot minus cot cancel. This is 1 plus 1, 2 cosecant theta. 2 cosecant theta is equals to k plus 1 by k. Okay. If I simplify this, k square. K into k square plus 1 by k. Okay. This is 2 cosecant theta. Okay. So what I am doing here, 2 cosecant theta is equals to k square plus 1 by k. Okay. Now 2 send it to the right hand side. 2 send to the right hand side. What you will get? 2k, right? Cosecant theta is equals to k square plus 1 by 2k. If I take reciprocal, then it will become what? Cosecant will become 1 by cosecant, right? 1 by cosecant theta is equals to 2k by k square plus 1. Take reciprocal. Because here 1 by cosecant square is what? Sine only, right? So that's the reason I'm writing sine theta is equals to 2k by k square plus 1. Therefore sine theta is equals to what? This is the sine theta. Okay. Then what is the sine square theta? Sine square theta is squaring on both sides. Then you will get sine square. Okay. You will get sine square. This is 2 2s are 4k square by this is k square plus 1 whole square. So this is sine square. But what is asking in the question? Cos is asking, right? So we know sine. We know the identity. What is identity? What is identity? Sine square theta plus cos square theta is equals to 1. Right, identity. This is identity. So we know sine square theta. What is that sine square theta? 4k square by k square plus 1 whole square plus cos square theta is equals to 1. Bring this term to the right hand side. Then what it will become? Cos square theta is equals to 1 minus 4k square by k square plus 1 whole square. So LCM, multiply here, 1 into k square plus 1, k square plus 1 whole square minus 4k square by k square plus 1 whole square. Okay, now here a square plus b square, expand this. A square means k to the power of 4, square into square, or else this is a square plus b square plus 2ab. A is 1, b is k square minus 4k square by k square plus 1 whole square. Okay, this is what cos square theta. This is cos square theta. Now here k square whole square plus 1 square, here 2k square minus 4k square, right, by this is k square plus 1 whole square. So what I am doing here, 2k square minus 4k square is what? Minus 2k square, right? K square whole square plus 1 whole square. This is minus 2k square. If I do simplify, 2k square minus 4k square is minus 2k square by k square plus 1 whole square. So what it will become? If I say this is 1, if I say this is a square minus b, a square plus b square minus 2ab, what is the formula? A square minus b square formula, right? So a square minus b square is a minus b whole square, right? A square plus b square minus 2ab formula, a minus b whole square formula, right? A minus b whole square, a minus b whole square by k square plus 1 whole square. Square square is there. Can I write overall square? Here what we have here, cos theta. This is cos square theta. Now cos square theta is equals to, overall we got k square minus 1 by k square plus 1 overall square. Can I write overall square? Now square square cancel. Can I write this is cos theta is equals to k square minus 1 by k square plus 1. Therefore we got the solution, and this is the solution. Okay, this is the required solution. That's all. This is the answer. Done. Show that tan square theta plus tan to the power of 4 theta is equal to secant to the power of 4 theta minus secant square theta. Now LHS. Try to consider LHS. LHS is what? Tan square theta plus tan to the power of 4 theta is equals tan square theta common. Tan square theta. If I take common, and then in the place of this you will get 1, and in the place of this we have tan to the power of 4 means 1 tan square remains, right? 1 tan square remains here. Power 4 is there. If I take common 2, then 2 remains. That's the reason I wrote 2 here. Okay. So we know that what is, we know, identity. Secant square theta minus tan square theta is equals to 1 is identity. Okay, is the identity. Now from here what I'm doing, just bring this tan to the right hand side. Can I write secant square theta is equals to 1 plus tan square theta, right? So I'm writing in the place of 1 plus tan square theta. Can I write secant square theta? I'm writing tan square theta into 1 plus secant theta can be written as 1 plus secant, 1 plus tan can be written as secant square theta, right? So what is tan square actually? If I bring this 1 to the left hand side, can I write secant square theta minus 1 is equals to tan square theta, right? So in the place of tan square theta, can I write secant square theta minus 1? I'm writing this. In the place of tan square theta, I'm writing secant square theta minus 1 into secant square theta. Now multiply inside secant square into secant square, secant to the power of 4 theta minus 1 into secant square is secant square theta. Therefore this is RHS only, right? This is RHS. Therefore LHS is equals to RHS hence proved, hence proved. That's all. This is the solution. Is this clear? Next. Here show that 1 plus tan square by 1 plus cot square is equals to 1 plus tan a whole by 1 minus cot a whole square is equals to tan square. Is asking to prove this is tan square a and this is also tan square a. Consider 1 plus tan square a by 1 plus cot square a. We will consider this and prove this. Okay. So we know that secant square theta minus tan square theta is equals to 1, right? So if I bring this tan to the right hand side, we can get secant square theta is equals to 1 plus tan square theta. That means in the place of tan can I write secant. Now this is a formula, this is also formula, right? From identity we derived this. So in the place of secant square, in the place of 1 plus tan square, we can write secant square. Alright, next we know cosecant square theta minus cot square theta is equals to 1. Okay, this is the identity 3, third identity. Now bring this cot to the right hand side. So what it will become? Cosecant square theta is equals to 1 plus cot square theta. So in the place of 1 plus cot square, can I write cosecant square? So I am writing here. In the place of 1 plus tan square a, I can write it as secant square a by, in the place of cot square, 1 plus cot square, I can write cosecant square a. From here cos square, we can write 1 by cos square a by, this is 1 by sin square a. Now we can write it as denominator to the numerator. If I this sign will comes to the numerator. Okay, sin square a by cos square a. Therefore this is 1 comes to the denominator. So sin square by cos square is what? Sin a by cos a whole square, right? So sin a by cos a is what? Tan a. So tan square a. Therefore this is tan square a. We got tan square a. Next consider one more. 1 plus tan a by 1 minus tan a. Cot a is there. 1 plus tan a by 1 minus cot a is there. So consider that one also. Okay. Consider 1 plus tan a by 1 plus cot a whole square. Okay. Now here 1 plus tan a. Tan a can be written as sin a by cos a whole square by, here 1 plus cot can be written as cos a by sin a whole square. So from here LCM do cos a plus sin a by cos a whole square by LCM sin a plus cos a, sin a plus cos a by sin a whole square. So here if I separate individually applying cos a plus sin a whole square by sin square cos square a divided by sin a plus cos a whole square by sin square a. So these two get cancelled, and from here this will moves to the numerator. So sin square a by cos square a. Therefore we will write it as sin square by cos square is tan square a. Therefore tan square we can write here. Hence therefore write this. Therefore 1 plus tan square a by 1 plus cot square a is equals to 1 plus tan a by 1 plus cot a whole square is equals to tan square a. That's all. This is the solution. Proving. We proved. Okay, that's all. Okay, we almost finished the chapter. We already finished. And in this chapter what we discussed? Sin A, cos A, tan A, cot A, all those in terms of sides. Okay. And in the Pythagoras, we learn Pythagoras, how to apply Pythagoras. Okay. Two sides are known, one side is unknown, we can find in the right angle triangle. Okay. In the values of trigonometries we discussed 0, 30, 45, 60, 90 degrees. Okay. Next. Sin A, cos A never exceed 1. Okay. Minus 1 to 1. Minus 1 to 1. Sin value lies from cos A also minus 1 to 1 only. Never exceed 1. Up next. Secant A, cosecant is always greater than or equals to 1. Okay. These are the important points. Next. Here we discuss the identity 1 sin square theta plus cos square theta is equals to 1, sin square a plus cos square is equals to 1, one only same. Secant square a minus tan square is equals to 1, cosecant square a minus cot square is equals to 1. That's all. These are the topics we discussed in this trigonometry and we finished. Okay, that's all.